Hello friends, we defined linear equations in one variable and linear equations in two variables. In linear equations with one variable, there is only one variable and the degree of the equation is always 1. In linear equations in two variables, there are two variables and still the degree of the equation is 1. Today, we will form the general forms of these two equations. In linear equations in one variable, there must be only one variable. Let's say the variable is x. And the degree of the variable must be 1, which implies that the highest exponent to which x can be raised is 1. Therefore, the general form of the linear equation in one variable is x plus b equal to 0, where a and b are constants and the value of a should never be equal to 0. In linear equations in two variables, there must be two variables, let's say x and y. And the degree of this equation is still 1, which implies that both the variables should be raised to the highest power of only 1. So therefore, the general form of a linear equation in two variables will be ax plus by plus c equal to 0, where both the coefficients a and b should never be equal to 0. Now, in the general form of linear equation in two variables, we concluded that the coefficients of x and y should never be equal to 0. Why is it so? Let's see what happens if any one of a and b is equal to 0. Let's say the coefficient of x is equal to 0. If a is equal to 0, then the equation will be by plus c equals to 0, and this equation by plus c equals to 0 is no longer a linear equation in two variables. It's a linear equation in one variable since the only variable present is y. Similarly, if we consider b equal to 0, then the equation will be ax plus c equals to 0, which is again a linear equation in only one variable, as x is the only variable. So this is the actual reason why the constants a and b should never be equal to 0. Now let's consider some physical situations and see how we could represent those physical situations as linear equations. Let's say there are 5 pens of the same type, and the cost of all the 5 pens together is 25 rupees. Now, how would we represent the same thing in an equation form? Tell me, what could be the only variable in this situation? The only variable that I could think of is the cost of each pen. So let's say the cost of each pen is x rupees. It is given that the cost of 5 pens is 25 rupees. Since the cost of one pen is x rupees, the cost of 5 pens will be 5x rupees and it is equal to 25. So we can equate 5x and 25. Now subtracting 25 from both the sides of this equation, we will get 5x minus 25 equals to 0, which can be rewritten as 5x plus of minus 25 equal to 0. If you observe carefully, the equation 5x plus of minus 25 equal to 0 is in the form of ax plus b equal to 0, where the value of a is equal to 5 and the value of b is equal to minus 25. So we can conclude that 5x plus of minus 25 equal to 0 is a linear equation in one variable. Let's consider a different situation now. Say, in a one-day international match between Sri Lanka and India played at Nagpur, two Indian batsmen made a partnership of 220 runs. Now, we need to express this information in the form of an equation. Let's do that. The contribution of neither of them is known. That is, there will be two variables. If we take the contribution of the first batsman as x and the contribution of the second batsman as y, we can get an equation x plus y equals to 220. Now, subtracting 220 from both the sides of this equation, we will get x plus y minus 220 equals to 0. Now, This equation is clearly a linear equation in two variables where the value of a is equal to 1, the value of b is equal to 1 and the value of c is equal to minus 220. So, the general form or the standard form of a linear equation in two variables is ax plus by plus c equal to 0 and the values of a and b must never be equal to 0. Now, let's do some simple exercises. Let's try to express equations in the standard form and find the corresponding values of a, b and c. So, the first one here is 2y minus 3 equal to square root of 2 multiplied by x. Before we try to solve this, first observe that this equation is not in a standard form. That is, of the form ax plus by plus c equals to 0. So our first step is to convert this equation into the standard form ax plus by plus c equal to 0. So the equation 2y minus 3 equals to square root of 2 multiplied by x will be rewritten as square root of 2 multiplied by x minus 2y plus 3 equals to 0. Now, on comparison with the standard form of the linear equation in two variables, the value of a will be equal to square root of 2, the value of b will be equal to minus 2 and the value of c will be equal to 3. Now, the same equation 2y minus 3 equals to square root of 2 multiplied by x can be rewritten as minus square root of 2 multiplied by x plus 2y minus 3 equals to 0. And again, this equation is also in the standard form. Now if you compare the values of a, b and c, and if you find them, the value of a will be equal to minus square root of 2, the value of b will be equal to 2 and the value of c will be equal to minus 3. Now what are the exact values of a, b and c? Do we have to consider this set of values or this set of values? Confused? Wait, let me clear your confusion. If you observe carefully, if I multiply both the sides of this equation by minus 1, I'll get this equation, which implies that both these equations are similar. So, we can consider both the sets of the values a, b and c. This time, let's multiply both the sides of this equation by 5. And doing so, we will get the equation as 5 root 2 multiplied by x minus 10y plus 15 equal to 0. Now let's again compare this equation with the standard form of the linear equation in two variables. Then the value of a will be 5 multiplied by square root of 2 and the value of b will be minus 10 and the value of c will be 50. And now from all these, what we have to understand is there can be infinite possible values of a, b and c when the equation is compared to the standard form. This time, let's say you have been given a question in your exam and the question is, you have to find the constants a, b and c when the equation square root of 2 multiplied by x minus 2y plus 3 equal to 0 is represented in the standard form of the linear equation in two variables, that is ax plus by plus c equals to 0. Here, there is only one answer and it is a equal to square root of 2, b equal to minus 2 and c equal to 3. Now, in this equation, we cannot multiply both the sides of this equation by any real number and we cannot change the values of a, b and c since in the question it is already mentioned that we have to find the values of a, b and c when this equation is already in the standard form. So, here the values of a, b and c are fixed and cannot be changed. So friends, I hope you understood how to form linear equations in one variable and two variables and also how to compare the linear equation in two variables with its standard form. In our next video, we will be learning how to find solutions to linear equations. As of now, let's summarize what we have learned so far. Linear equations in one variable will contain only one variable and the degree of the equation will be 1. Standard form of a linear equation in one variable is ax plus b equal to 0 where the value of a is not equal to 0. Linear equations in two variables will contain two variables and the degree of the equation will still be 1. Standard form of a linear equation in two variables is ax plus by plus c equal to 0, where the values of a and b should never be equal to 0.